All right. With the select number, or reduced number, I should say, students that we have here, some of these questions we may have gone over. These are in purple. I think we have gone over these. These would have been the last few that came from the video about athletic limits. Okay, that had the ultra marathon competitor, then also had the basketball player, Ms. Becky Hammond. It also had the rock climber, and there was one more, a swimmer. I think it was a brother and sister swimmer that was included in this video. And then the blue is what we had observed. It was called surgery. Is it a kill or a cure? And about the history of how far medicine has come along, because how do you actually know what's inside the human body without looking? And of course, you wouldn't have an answer for that. So in this case, that's why we had the opportunity to look at that on, I believe it was last Thursday, or maybe it was Friday, one of those 2 days, I believe. And if nothing else, this is good practice for probably a lot of the same students that are gone today will be individuals that will be participating in track and field next year. And how do I want to state this? Being gone only compounds the issue when it comes to problem solving. This is just straight up life science and vocabulary and making different types of correlations with structures. Problem solving altogether is different. So for those of you who take general chemistry, this is again a good practice or good dress rehearsal for what it's going to be like next year. And some of you do have experience with this from last year when it comes to that of physical science. All right, so do these look familiar? What is the nutritional source for swimmers? It's fats. That's right, because that's something that not only do you have to have that to insulate the body, there's just not enough sugar, cannot just provide enough energy to cross that channel, which was, 26 miles, just like a regular running marathon. So, and we would have noticed this too when we looked at the mink. Why is the intestine shaped in that particular manner inside of the abdominal cavity, whether it's a mammal or a human? Well, true. Just because it fits doesn't mean that's going to explain its correlating function. Because what did you notice when you took the intestine out? Why is it important that it's so long? You're right. It's going to be broken down, but the absorption is the important part. Yes, it's broken down, the intestines, but you have that length of intestines to absorb all the nutrients. That's why that's important, okay? So go ahead and write them down. This one was fats for the top one. Then this is for absorption. Not so much the digestion is a vague term. It's the absorption that's more important. What are the painkillers in the brain called? Dopamine, serotonin, melatonin, any of those? None of those. Actually, starts with an E. They're called endorphins. Okay, those are natural painkillers that the brain actually produces, and it's just it's a way that you could say almost keeps us healthy. Should we ever be in a stressful situation to where there's trauma to the body, this will numb the pain just long enough for us to get to safety. Let's say, for instance, you get run over in the middle of the street. Okay, you're just walking along, and then you get toppled over the vehicle like this, okay? And then if you break a leg, which is going to be obviously quite painful, your body will produce endorphins enough to numb that pain. At least this is theoretical. I think that's something you don't want to try, but there's documented cases that would say that these endorphins will numb that pain long enough for you to get to, per se, safety for treatment. It might happen in rock climbers too. Should you fall and break a limb, your body will compensate for that by producing endorphins until you get to safety. And then that's when the pain probably really sets in. But natural painkillers produced by the brain, endorphins. Okay? How does the skin present damage from spreading? Okay? Is it scabs? Is it calluses? Or is it blisters? Okay. If it's not due to slight friction. If it's major friction, like in your shoes, then it's blisters. Okay? But if it's on your hands, then it's probably calluses. So, blisters. Okay? The first anesthetic was a gas. Do you remember what it was called? It's got two names. This one was one of them. That doesn't look right. That looks a little better now. So, laughing gas, but it's got a more scientific name. It was called nitrous oxide. Okay? Now, one of the problems with that is that it had really bad side effects, nitrous oxide. Okay? Yes, ether was a type of anesthetic, but it was not, let's say, approved to be the first one, because what had happened is a dentist tried to use ether. He didn't give enough to his patient, and then it goes on to state, what did that young boy do? He woke up, kicked him, and walked out of the room. The reason that's important is at that time frame, there's lots of influential people within the scientific community that would look at that and say, we can't accept ether. Okay? So that wasn't the gas of choice. Then there was a second anesthetic. Starts with a C. Chloro something. Remember? Obviously not. Okay. It's called chloroform. And that's something that you could ingest internally. And what your body would do is actually absorb that, and all throughout the body would just become numb. And it wouldn't be permanent, or else it wouldn't have been one of the anesthetics that was per se accepted. But chloroform was the second one. Nitrous oxide 1, chloroform 2. For microorganisms, what's the human body's first line of defense? That's in response, not a defense. Not a bad answer. It's once this breaks open, then the body can have problems. Oh, your appendix? Well, that's on the inside. What's on the outside? You're going to go, what is dermis and epidermis referring to? Skin. So the first line of defense against microorganisms in the human body is the skin. Okay. I do not. I do not have bus route today. The first documented surgeons that said by default has this spinning deal outside their store or storefront. You know you're going to this place. give you a good shave. Barbers. Barbers were the first documented surgeons. The reason for that, why barbers? Because you have to remember, at this time frame, it was not accepted or ethical in society to cut open the human body. There were too many, let's say, religious beliefs that prohibited that. So how else do you learn what's inside the human body? Well, that would be tough. The only place that you could do that is at medical institutions. And in that case, that's where you had the case of the body snatchers. And each school was only given 2 cadavers per year. So I can about imagine what that would be like for an entire medical school trying to learn what's inside the human body with just 2 cadavers. Heck, if you were to go down to USD, I believe they would probably have, since it's a medical school, maybe upwards of 15 to 20 people who have donated their bodies to science. It's what they chose to do. It was their choice to become a cadaver, not the family members. So they choose to do that, and that's what we had observed up in Brookings yesterday. And that is quite an experience for those of you who choose to take human anatomy and physiology. There's nothing that can prepare you for what you think the human body looks like on the outside and on the inside until you actually see it. Okay, so anyway, good experience for that. So tomorrow you have your second vocabulary evaluation, and it's going to be a quick turnaround, and you will have your exam, chapter 32. Just general questions, okay, and vocabulary. And then next week, we will have you take part 2, okay? So, where do you suppose is a good place to look for information on part 2? Not the Science Channel. The drop folder. That's right. Okay, so what you can do, so between now and next Wednesday, because Monday you're in Del Rapids for track. Tuesday, you're scheduled to be in Alcester Hudson for track. Okay? So with that, next Wednesday will be part 2. So what can we find in the drop folder? Okay? You go to the drop folder and go to biology. And here's the bones and muscles diagram. It's got diagrams on there. It has them pointing and it has the names of them. Okay, wouldn't be that. You're not doing circulation. There we go. Okay, so it has the posterior side, the anterior side, then it's got the skeletal system, the front and the back. Okay? Do you have to know all of these? No. How do you know which ones you need to know? If you wrote them down, I bet that would be a good place to find them, right? Vocab sheet. It's not on a vocab sheet. Back to the drop folder. Biology, bone names, and MUS means muscles. Okay? Should you have chosen to do this, this was wrote up on the board a long time ago. This is also in the drop folder. Okay? Bones here on this side, okay? And here are the muscles in red. Okay, so you are speaking for your classmates. Is there any? Okay. So I don't know when this started blinking, because once it does that, I don't know if it still picks up sound. So these are bones in the black. These are bones written here in the black, and here in the red are the muscles, okay? And then this is part 2. And part 2 is when? Next Wednesday. So again, this is in the drop folder. This is also in, oops, I thought it would go in between there. This is also in the drop folder. Okay, so again, you are speaking for your classmates. Is there any questions that you feel you need a little more clarification? If not, that's correct. You just point. There'll be, for instance, it won't be this exact diagram, but something comparable to it. Okay? So, of course, you would have all of this cut out and just the muscles left behind. And has anyone seen this before? No? Okay. Do we recognize any of these muscles? Okay. Biceps is right here. That's true. And the triceps is behind there. And when you look at those two muscles, they form a what type of joint right here? Looks like how does the door swing open? On hinges. Okay? So that is a hinge joint. So if the angle is quite large here, this angle, is that flexion or extension? Extension, when there's a wide angle. When you decrease that angle, then it's flexion. Okay? Where is there a ball and socket joint?
Shoulder.
There's one here, there's one here, one there. Okay? Yeah, the shoulder. That's what we're pointing at. You actually have to look underneath here. All right. Where would you find immovable joints? There's only one place in the body you find them. And it's bones that absolutely should not move at all. At one time they used to. Those are slightly movable because you can move from side to side just a little. Ribs? Nope, not ribs, not calves. Got to go a little higher. Little higher. Little higher. Little higher. The cranium has what's called sutures in them. Okay? And it is those sutures that we would refer to as immovable joints. Okay? So what we're looking at here, joints up here, you can see a zigzag line. I don't know if you'll be able to see it on your drop folder, but those are sutures. That's immovable joint. These are slightly movable. There's a ball and socket like we talked about. And then here's a hinge joint, another hinge joint down here. Okay, I think there's only 4 on that page in your book, those 4 types of joints. All right, anything else? Front row. Again, you're speaking for your classmates. Second row.
Are we getting those questions tomorrow?
Yes. Third row. Nothing to add. Okay. So yes, bonus questions will be given out tomorrow. Should we think we need them? Do we deserve them?
Yeah.
Okay. We'll catch up to you next time.